Hello friends, and welcome to another lecture on operation research. Today we'll be looking into a transportation problem, and we will solve it using the column minima method. So such methods are best understood by taking up an example. So let's go ahead and take the example. So the example is on your screen now. What we have is, yes, a dairy firm has 3 plants located in a state. Daily milk productions at each plant is as follows. Plant number 1, 6 million liters. Plant number 2, 1 million liter. And plant number 3, 10 million liters. The daily demand from the distribution centers are distribution center number 1, 7 million liters. Distribution center number 2, 5 million liters. Distribution center number 3, 3 million liters. And 4 is 2 million liters. Now the cost of transporting milk from plant to distribution centers is given in this table, right? So how this table is understood? Well, let's say you want to supply milk from plant number 1 to distribution center number 3. It's going to cost you 11,000 rupees for a million liters. Let's say if you want to transport milk from plant number 3 to distribution center number 2, it's going to cost you 8,000 rupees for a million liter. Now, how do we solve? How do we optimize the supply to the demand so that the cost of the overall supplying is minimum? For that, we copy down this table. So we have to copy down this table, and I have copied down the table for you, and there it is. Now, in this table, I have introduced a column on the right hand side and a row on the bottom. Now, in the column in the right hand side, I write the supply from each and every plant. And in the bottom row, I write down the demand from each distribution center. So the supply from plant number 1 is, let's reduce the size. Okay, there we are. Fine. So the supply from plant number 1 is 6 million liters. The supply from plant number 2 is 1 million liter, and the supply from plant number 3 is 10 million liters. Okay. Now the demand from distribution center number 1 is 7 million liters. The demand from distribution center number 2 is 5 million liters. The demand from distribution center number 3 is 3 million liters, and that from distribution center number 4 is 2 million liters. Now, as we can see here that the summation of the demand is equal to the summation of the supply. So this is a balanced problem. In transportation problem, we can only solve balanced problems. If there are unbalanced problems, they have to be converted into a balanced problem, and only then we can go ahead with the solution, right? So this is a balanced problem, and we can go ahead with the solution without resorting to any other techniques to make it balanced. Yes, that said, how do we use the column minima method, which we are going to learn today? So there we are. Now in the column minima method, we take up the distribution of each center serially. So we start with distribution center 1, then go on to distribution center number 2, then to 3, and then to 4, right? Now, while calculating the supply to distribution center number 1, we first supply, okay? We first supply at the least cost. I'll explain it. Now, from plant number 2, if we need to send it to distribution center number 1, the least cost of supply is 1. So, we take the supply from plant number 2 and give it to distribution center number 1, because this is at the minimal cost or the least cost. Now, there is still a surplus demand of 6 million liters in distribution center number 1. Now, again we look into the column and we see the next highest cost. The next highest cost is 2. The demand is 6. Now we can take the supply from plant number 1 entirely and give it to distribution center number 1. That is 6 million liters. So now the demand from distribution center number 1 has been met. The supply from plant number 2 and plant number 1 are totally given to distribution center number 1. So we strike them off. Right? Now the optimization that we have done in this cannot be done for other distribution centers. Well, because all the milk supply from plant number 1 and plant number 2 have been given to distribution center number 1. Therefore, now what remains is only plant number 3. Now from plant number 3, we give 5 million liters to distribution center number 2. So the demand from distribution center number 2 is met. Then we supply 3 million liters to distribution center number 3. The demand of distribution center number 3 is also met. And finally, we give the last 2 million liters to distribution center number 4. And the demand of distribution center number 4 is also met. And this 10 million liters from plant number 3 is totally distributed to 2, 3 and 4. As you can see, we have done it in a serial wise fashion, looking into the demands of the distribution center. So finally, all the demands and all the supplies have been balanced off. Now, what is going to be the cost of this operation? It's nothing but, because it is in multiples of 1000 rupees per million liters. So we are going to write 1000 into 2 into 6 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2. And that comes out to be rupees 116,000 for the entire operation. Now just have a look at the link on the top. That is, the same problem has been solved using the northwest corner method. The optimized cost using the column minima method and that of the northwest corner method is the same. But you will also find in the same playlist a video on the row minima method, which gives you an optimized cost which is lesser than the cost we have obtained here. So depending on the nature of the problem, the row minima method or the column minima method might give you the optimized cost. But these are very rudimentary methods of getting the optimized cost. They are the first case for optimization. Right? Now these optimized values can be improved on by other techniques, which I will be discussing later on in the videos. Okay, keep watching. So that was all about how to use the column minima method to find the optimal cost of supplying to distribution centers. If you like this video, give it a thumbs up and subscribe my channel. The entire course of optimization operation research will be taken up in this playlist. So there's a lot more coming up, lot more learning coming up. Okay, and do subscribe our channel. Goodbye. Have a great day.